and share screen. Okay, so I'm always very happy when you're doing your hallway math. I see some great collaboration outside, but I do also, I'm going to reveal obviously a document with all the answers. And in the video today, I'm going to try to get through as much examples as possible. So we start off very simple with a monomial in the numerator and a binomial in the denominator. This is a very straightforward calculation. So remember, h of x means that my derivative is going to be equal to h prime of x. I have my derivative of the top, positive 1, times the derivative times the original bottom function, minus, so unlike product rule, quotient rule has a difference in the formula. The derivative of the bottom now times the original top function all over the bottom function squared. So you can be looking in your notes to make sure that you were able to get this far. After this, it's a very straightforward distributive property calculation. So I get x plus 1 minus x all over x plus 1 squared. And just to make sure, because sometimes you're going to be solving for many different items in the question, I want on every line to specify, I'm solving here, miss, for the first derivative. Because remember, as we move on later in the course, we're going to have to calculate second derivative and other items related to this question. So my total answer, my final answer, sorry, is 1 over x plus 1 squared. Very, very straightforward question. So we'll move on to the next. So here I have a binomial in both the numerator and the denominator, 2t minus 3 over t plus 5. Again, we're going to start off with writing what we're solving for, the first derivative. And so I have the derivative of the top 2 times the derivative, the original bottom function minus the derivative of the bottom times the original top function all over my bottom function squared. And obviously students have that question, when do I expand, miss? When do I factor? And it really depends on the question. We can see here that there's no way our numerator is going to simplify to a quadratic function, right? We have, when we do our distributive property, 2t plus 10 minus 2t plus 3 all over t plus 5 squared. Now, if this was a quadratic function that I could possibly cancel with the bottom, then I might want to write that as t plus 5 times t plus 5 so that something could cancel out. But because my numerator is very straightforward, and I'm going to remember to write what I'm solving for on the left-hand side, I don't want floating equal signs. That's going to be equal to 13 over t plus 5 squared, and no need to expand that to simplify. Okay, so very simple. Hopefully everyone got that when you were doing your hallway math. Okay, now we're going to move into something slightly more complex. So I have h prime of x is equal to, I want to take the derivative of the top. Because I have a cubic function, I know my derivative of the top is going to be one less than a cubic function, which is a quadratic function. So we can store it here. So that's going to come up to 3x squared. Now times the original bottom function, 2x squared minus 1. Right away, I know an x cut to the power of 2 times an x to the power of 2 is going to give me x to the power of 4. So in my head, I'm thinking there might be the possibility that I have to factor this, right? As we get higher up there, and I'm going to be prepared with my long division and synthetic division, but I'm not jumping to that conclusion yet because I want to see what the rest of the question has in store for me. Now I have the derivative of the bottom, which is 4x times my original top function, x cubed, all over the bottom function squared. 2x squared minus 1 squared. Okay, I don't want to tackle the bottom yet until I simplify the top. So h prime of x, I know going into this might be something I need to factor. 6x to the power of 4 minus 3x squared minus 4x to the power of 4 all over 2x squared minus 1 squared. You have a link slip, right? Okay, thank you. Now be very careful. The 6x to the power of 4, negative 4x to the power of 4, those are like terms. So I want to keep going. H prime of x is going to give me 2x to the power of 4 minus 3x squared over 2x squared minus 1 squared. Now I want to look at this very carefully. Yes, I do have x to the power of 4x squared. There is a greatest common factor there of x squared. But even if I take that out and I'm left with a 2x squared minus 3, that is not something that's going to cancel with the bottom, right? And the greatest common factor does not cancel out at all. So I can write this with the greatest common factor taken out, or I can leave it like this. It's not essential because there's nothing to cancel out. Okay, so it might mean on your scrap paper, you're playing around with this a little to see if you can simplify. And if you have a doubt, just keep going. I would just end up finishing my marking right here, right? It doesn't hurt to try to simplify further, but I would leave my answer like this. The next question is very straightforward, so I'm just going to write the answer here. So you can double check with the work that your group members did. And the same thing for the next one. I'm trying in this lesson to tackle the more difficult questions as much as possible. So for this, now I want to point out, because the original function is a y, my proper notation for the derivative is dy over dx is going to be equal to 5x squared plus 6x plus 5 over 1 minus x squared over 1 minus x squared squared. Now, you might be thinking that, hey, Miss, the numerator has a quadratic function, right? But first of all, can't factor that using a standard binomial, only the quadratic formula, which would not meet any of my needs to potentially cancel out the binomial expansion in the denominator. So I'm going to leave it like this, right? No need for decimals in the quadratic formula unless you're solving for a specific point, which would require word problems, right? You will find that a little bit in your unit guide, but not for straightforward derivative calculations. Okay, the next question we're going to go in detail, and we have a trinomial quadratic function, and I also have a quadratic function in the denominator, okay? And very similar to the last question. Again, I'm starting off with dy over dx because my original function is in the form y is equal to. Okay. I'm going to take the derivative of the top, which would give me 2x minus 1. And remember, when you hear me say I'm taking the derivative of the top, I'm applying the power rule, right? Power rule is something simple. You're not showing any steps, you're just doing it in your head. That means a power rule question would not require steps, but product rule and quotient rule definitely does require detailed steps. I'm multiplying this by my bottom function minus the derivative of the bottom function, 2x, times my top function over the bottom function squared. And remember, kids, sometimes I see students writing this and they think x squared plus 3 can cancel with x squared plus 3. No, this is just writing the quadratic formula, the quotient rule out. You cannot cancel until all distributive property has been conducted, the algebraic manipulation has been conducted. You're always going to be able to cancel things in the quotient rule formula. That's not what it's meant to do. You're not going to get anywhere if you try canceling too early, so please be very careful with that. Now, when I perform, and remember, this is going to be the distributive property in the second part, but the first part you have to conduct FOIL. There is no easy way to get the answer without FOIL. So I have 2x cubed plus 6x minus x squared minus 3 minus 2x cubed now, the distributive property part, plus 2x squared minus 2x. You have to be very careful with the distributive property because the numerator has a negative, right? So that negative makes the 2x also negative. When you're applying the distributive property, do not treat it as a positive 2x. All over the bottom squared. And it wouldn't be wrong if I wrote that as x squared plus 3 times x squared plus 3. That would be the same thing. Now, when I simplify everything in the top, you have to show me that. It's very important that you don't go from the FOIL and the distributive property straight to the step that I'm just going to write. It's really important to show me the FOIL and the distributive property so I can follow how you are getting the right answer. Especially true for virtual students who are at home writing this. X squared minus 4x minus 3 over x squared plus 3 squared. Now, if this was a positive 3, x squared minus 4x plus 3, there is a way of decomposition, trial and error, factoring that in order to get two binomials that still wouldn't cancel out with the bottom, but if you cannot factor it, you leave that quadratic equation just the way it is. So a good skill from grade 10 that you might want to practice would be factoring. Okay, how much farther? Just want to see how many questions we have. We have quite a bit. So this is a question I do want you to practice in class today to make sure you're getting the right answer. In case you didn't get this far in our hallway math, is equal to 13 over x plus 5 squared. That would be the first part, calculating the derivative. Now it's asking the value at x is equal to -3. So what that means is by substituting x is equal to -3 into the equation, you would actually show substitution 13 over, I should write that down, 13 over -3 plus 5 squared. That's going to give you a value of 13 over +4. 13 over +4. Okay, seem to misplace something, so I'm just going to quickly stop sharing and pause lay. Okay, this is an example where we do not have to simplify fully, completely, all the way through, because at some point we can use the direct substitution. Now, this only happens when you're given an x value. Otherwise, you always have to simplify fully. So again, I'm going to start with dy over dx to represent my derivative, because the original equation is y is equal to. Now, I'm going to solve this just a different way. On test, mostly I want to always see the FOIL and your distributive property, but I'll show you what happens and how complex it can be when we go into the direct substitution. So the derivative of the top would be 3x squared. X squared plus 9 is my bottom function. The derivative of that is 2x times x cubed, the original top function, all over the bottom function squared. Just want to double check that it's recording. Yes. Okay. Now, it's always a good idea to simplify further, but I'm going to show you how you can run into problems sometimes if you go straight into the substitution. It gets a little bit complicated. Now, it's easier to follow because x is equal to 1 is such a small number. But if I do this, dy over dx, now again, I'm not suggesting doing this on the test, but look what I have to come up with. So if I use substitution there, I have to make sure that I have, every time I see an x, I'm substituting +1. I have to use my brackets correctly, because then I'm not going to be using the proper FOIL distributive property rules correctly, minus, now I have 2 times +1 in square brackets, all over 1 cubed, okay? And this might make sense to you because we're using +1. But even if I make one little error in this, my answer will fall apart. That's why I'm suggesting, as much as possible, simplify the equation first before you do the substitution. However, if you do the substitution correctly, it will still result in the same answer, but I'm not recommending doing direct substitution. So I have 30 minus 2 over 100 The only time I would recommend to do this is if you're running out of time on the test and you just want to get some work done for part marks. Okay. And so our answer is 7/25. The next question is really related to homework questions that I was really happy to get some consultations with calculus students yesterday. And something like this came up in the homework a lot. Find the points at which the tangent to the curve is horizontal. Raise your hand if you got to this point when you were doing your hallway math. You get up to this point? Okay, good, good. So I have y is equal to 2x squared over x minus 4. So dy over dx. Start off always with the derivative. And I have my derivative of my bottom function, sorry, the derivative of the top function, which is 4x, times my bottom function, x minus 4. Subtract the derivative of the bottom function times my original top function over the bottom function squared, x minus 4 squared. Okay, if I apply my distributive property correctly, I'm going to get 4x squared minus 16x minus 2x squared all over x minus 4 squared. And again, this is dy over dx. And to simplify, that turns into 2x squared minus 16x. Notice there's a greatest common factor clearly there over x minus 4 squared. Okay. Now, what does it mean for the tangent line to have a horizontal slope? What does that mean? Andy?
Slope of 0.
Yes, the slope is 0. So where am I going to put that slope of 0? Am I going to substitute it where I see x into the equation? No, I'm going to set the derivative formula equal to 0. Now, some students get confused and think this is 0 over 0, so everything becomes 0. That's not the case. When you're truly solving for this, in terms of cross multiplication, the 0, I know it might not intuitively make sense, but the 0 you're only cross multiplying the x minus 4 squared with the 0. So when you have to set your derivative function equal to 0, only the denominator is affected. And what happens now is the left-hand side becomes 0, but whatever was in the numerator for the right-hand side still continues to exist. And that's what some students had the difficulty with. So now I can continue to move forward, and I will do that by taking my greatest common factor out. The greatest common factor is 2x. I'm left with x minus 8. Okay. How many values, how many x points? Because remember it said find the point at which the tangent to the curve is horizontal. How many points does that equation give me, Joseph? 2. Yes, very good. 2 points. Let's see. So I'm going to draw little arrows to help you show. So that leads me to one equation, and this is going to lead me to another equation. The first equation is 2x is equal to 0. So when I divide both sides by 0, that's going to give me the x coordinate. X is equal to 0 divided by 2 is obviously 0. So x is equal to 0 is a possible x point. Oh, it's not liking my mask at all. Now, when I take the second part of this equation, x minus 8, set that equal to 0. That means that x is equal to positive 8. Now, is that enough to answer the questions? I have 2x, well, I don't even know what components, and it's not enough because in order to have a point consists of an x and a y. So I have to keep going here. But it's really important that when you keep going, I'm not substituting I'm not substituting this x is equal to 0 into my derivative function. I need to substitute it into the original function. So the original function is y is equal to 2x squared over x minus 4, right? So what I'm really solving for is f of 0. So I'm substituting, when I see an x, I'm substituting 0 squared over 0 minus 4. So that gives me a y coordinate of 2 times 0 squared is 0 times 0 minus over 0 minus 4. It doesn't matter, 0 over any number is 0. So when x is equal to 0, y is equal to 0, we call that the origin, and the origin is part of our graph. When x is equal to 8, this would be 2 times 8 squared over 8 minus 4. So y is going to be equal to positive 32. So I have from this answer, the solution, 2 possible points that would lead to tangent lines that are horizontal. And therefore, my points would be 0, 0, and 8, and 32. And there is a few questions in your unit guide that relate to this concept, so please commit that to memory. Okay, we're getting there. I have 2 examples left. The next example, did anyone get this far? Raise your hand if you got this far in your hallway math. Okay. I like this example because it requires some cross canceling. Again, not when you're applying the quotient rule, but later on in the process. So I'm going to remember to start off with dy over dx and not f prime of x. I'm going to take the derivative of the top function, 2x. I'm going to multiply that by the original, and that's going to give me quite a long trinomial when I'm doing my distributive property, but that's okay. Then I'm going to take the derivative of the bottom function, which is a binomial, and multiply that by the original top function, which is also a binomial, all over the bottom function squared.
Would Jody Pasadena please report back to music? Jody Pasadena, report back to music now.
So dy over dx, 2x cubed. Please correct me if I'm doing anything wrong. Plus 2x squared minus 2x times negative 2 is negative 4x, right? And then I have, so this is what I want to see. Then you want to do your FOIL inside the brackets so that you can distribute that negative after, right? So inside the brackets means this is 2x cubed, negative 2x, positive x squared, minus 1. All over x squared plus x minus 2 squared. Okay, Obviously, I want you to also show me now applying that the second derivative rule, which would change everything in this side of the brackets, change the sign of everything in this side of the brackets. To change, to save some time, I'm just going to skip that step right now and simplify it. X squared minus 2x plus 1 over x squared plus x minus 2 squared. So in all the examples I've done so far, I've kept saying, oh, the numerator and the denominator don't have anything in common. Factoring would not make sense. But here is a question where factoring definitely makes sense to simplify this. Dy over dx. Any ideas what the top simplifies to if I had to factor this? Anyone know? It's straightforward. X squared minus 2x plus 1. Anyone? Sarah? Maybe? Yes? Yes, x minus 1 squared. Excellent. And let's forget about this little squared on the side. How would you factor, or anyone in the room, x squared plus x minus 2? Any ideas? Okay, so if we were just factoring that, it would turn into x minus 1 times x plus 2. Now, they say square that, right? So I would actually have both of these binomials squared. That's what that means. Now we have to be very careful. Because of that power of 2 over here, it means when I'm canceling, oh, wait, no, it works out perfectly because the numerator has x minus 1 to the power of 2. The denominator has x minus 1 to the power of 2. Those cancel out completely. So canceling out common terms only happens when everything is completely factored out. When after you've done your FOIL, after you've done your distributive property, it would be trickier, and please ask me in person, one-on-one. If this was x minus 1 to the power of 1, and this was x minus 1 to the power of 2, then it would be trickier. It wouldn't cancel out perfectly like that, okay? So if you know how to do that on your own, that's great. If you need some help, I can obviously give you some guidance with that. That is a trickier. I don't think you had too much practice with different power cancellation in MCR. So that means that the derivative is equal to 1 over x plus 2 squared. Now, this was the same situation as the last question, where they wanted to find out where if there was any points that had a horizontal tangent. So now, oops, I forgot to write something, x plus 2, there we go. What happens if the left-hand side, if I set my derivative equal to 0? What happens now, Joseph? One over 0, right? Because it would this would cancel out, right? But that doesn't mean that x is equal to 0 like before. The x has been eliminated as well. So when you get into a situation like this, where you have 1 in the numerator and the denominator is being eliminated, this is actually a solution which you would write no solutions. And if you actually graph this, you will see there is a hole in the graph when x is equal to +1. We know that by eliminating the removable discontinuity, right? So there's a hole in the graph when x is equal to 1, and there's no solutions, no points that yield a horizontal tangent line. Everyone okay with that? Yes.
So the reason why is because there's no x at all. It's being canceled out. So it's one.
Yes, yeah, there's no solutions to this. There's no value of x that the graph and the tangent, where the tangent is going to be horizontal. Okay, let's do one last question before class is over. And I think that was the last question I actually gave in hallway math. Determine the equation of the tangent to the curve at x is equal to 2. Okay, so we've done questions like this before, but we've done questions like this that involve the product rule, the power rule. Now we have to involve the quotient rule. Okay, so the first thing I'm going to do, and I've in our notes extensively labeled step 1 as the common point. And this is where we're not using the derivative function, we're using the original function. So at x is equal to 2, we're solving for f of 2, which is going to give me 2 squared minus 1 over 3 times 2. And if we simplify this, this is equal to 1/2. So what that means is my common point that I'm going to be using to figure out the equation of the tangent line is when x is equal to 2, y is equal to 1/2. That is step 1. Step 2 is going to be determining the equation, my dy over dx. So dy over dx is going to give me, I can't see the formula right now, but I know to write out the quotient rule, it should be 2x times 3x minus the constant number 3 times x squared minus 1 all over the bottom function squared, 3x squared. So dy over dx will be, this is a straightforward application when you're using the distributive property, 6x squared minus 3x squared plus 3 all over 9x squared. When I get rid of grouping like terms, I will get dy over dx is equal to x squared plus 1 over 3x squared. Please keep in mind, kids, just because you see x squared and 3x squared, that does not mean that's something common that can be eliminated. The x squared plus 1, that's a binomial. They're stuck together, right? The only thing that would eliminate that would be another x squared plus 1. So you cannot treat a binomial as two monomials. You would only be able to cancel a monomial with a monomial. So I know some students have some trouble with that. So please practice that skill, or that has been an issue on past tests, I should say. So what do I do with this derivative equation? I have the derivative equation. We've done a number of examples when we're solving for the equation of a tangent line. What comes next? What comes next? What do we use the derivative to solve, grade 12? Kim. Thank you, Kim. So step 3 would be to find the slope of the tangent line. And so basically, I'm taking dy over dx, substituting x is equal to 2 into the equation. So I would get 2 squared plus 1 over 3 times 2 squared, which is going to give me a slope of 5 over 12. And I can use this slope and the common point to find the equation of the tangent line by writing down, everyone shout out, which linear equation from grade 9 do we use? Which form? That's a grade 12 Friday morning answer. Y is equal to mx plus b. So I substitute for my common point over here. I substitute for my slope over here. And what that looks like is 1/2 is equal to 5 over 12. Lost my screen and I don't remember the other. Oh yeah, x was equal to 2 plus b. This simplifies to 1/2 is equal to 5 over 6 plus b. If I isolate my b, and I want to change it to a common denominator, 3 over 6 minus 5 over 6 is equal to b. That means that b is equal to -2 over 6, which is the same as -1/3. Therefore, now I can come up with the equation of the tangent line now that I have the y-intercept and the slope. You'll remember that my slope was 5 over 12 x and my y-intercept is -1 over 3. Okay, so you're all this is kind of another form of studying, going through all of these practice questions. One thing I told everyone who consulted with me yesterday on our first SEL day is, in addition to this, your unit work, your extensive seminar notes, I've always published at the beginning of all of my calculus courses the link to the courseware of University of Waterloo site. Teachers like myself have contributed to that, so that's notes based on calculus. And in those notes in the courseware University of Waterloo site, there are practice questions for power rule, product rule, quotient rule. They have full solutions as well. So if you want to really feel prepared for Monday, it's not Tuesday's test, it's Monday's test, please look through that and make sure you're comfortable solving your unit guide questions, my lesson questions, and for extra practice, the University of Waterloo questions as well. I'm going to just stop recording for a